Sekejap, eh. Boleh nampak, eh? Let I zoom it bigger. So this is a lesson plan for the BFC 25203 numerical methods. So in this course, it will cover the numerical solution to solve nonlinear equations, system of linear equations, polynomials, numerical differentiations, integration, eigenvalue, and also ODE and PDE. So I guess you may familiar with those topics. Some of them you already learn in the calculus and also your mathematics engineering, right? Engineering maths before, right? Okay, so in this course, we have 4 lecturers. Me, myself, I'm teaching you in section 1, and Dr. To will teach section 2, and another 2 lecturer from FKEE, Dr. Maslina and Dr. Farhana will teach section 3 and 4 respectively. Okay. For the course learning outcome, okay, CLO1, the first learning outcome for this course is to analyze the numerical method to solve engineering problems correctly. So at here, you have to look at the taxonomy level C4. So what is the C4? So in this course, you will assess based on the level C4. That means more on the questions, either test or final or even like assignments will be more on analysis. Okay, so you have to analyze. Okay, so why it is so important you to know this C level is actually kenapa here I want to explain to you. So in this case, if you look at the question in test and final, you have to analyze, not only just give you the formula and then you apply. Any of you know about the taxonomy level or not? Alif here, Muhammad Alif. Pernah? Do you hear? Pernah Alif Ashraf? Pernah dengar pasal taxonomy level? This you are year 2 already. Year 2 kan? Pernah dengar?
Tak pernah dengar, Doktor.
Okay, so before this previous courses, lecturer never explain to you this one. Kau dengar macam tu ke awak tak masuk pun? Didn't attend the first class. Okay, let I try to search the Bloom. Wait, I find something for you and then I explain to you. Since today is the first class, so kita jangan serius sangat Tapi saya nak mengajar lah. Wait, I find some. Why I tell you this one? Because later on you will see the questions in this course will be more on C4. C4 is the level of analyzing. So you will see in your question test final will be more on calculating, or maybe you have to do like estimate and how you explain. Basically, saya besarkan mungkin I show. Wait, I stop sharing this one. Wait, I show the entire screen. Jangan tidur If you are sleepy, then you can go and drink some coffee. Belanja sendiri-sendirilah Okay. Can you see this one? Can you see this one?
Yes.
Right. Okay, you look at this one, If C1, this one, boleh nampak sebelah sini, saya maybe I have to like save this image and then it will be more, wow, final exam keluar. Wait, I put in the desktop. So open is in the desktop. Boleh nampak. Okay, this one. Look, this one. So if let's say this is a C1, if let's say taxonomy level C1, that means you will be assessed more on remembering. So we will ask you to define blah, 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 the formula or something like this. If C2 is more on understanding, we will ask you, okay, how, or maybe choose which one and compare this method and another method. Okay, that one is we want to know whether you understand that particular topic or not. If apply, okay, normally we will ask you to use, okay, using this formula and then calculate blah, blah, blah. Okay, so that is a C3, applying. So in this course, mostly you will assess based on the taxonomy level of C4. That means analyzing. So calculating and do some mapping. This one lah, okay, basically estimate, calculate. Didn't means that apply C3, not calculate. No. And then if let's say C5, maybe in your test and final, you also will have the test and final questions on C5 level. That means evaluating. We ask you how, why. Let's say you have a result, you get the answer, and then we will ask, how if I change this data to another data? So what can you predict? This one is more to C5, okay? And then the last taxonomy level is C6. C6 is more on creating. So this C6 normally for the courses for the final year subject, final year courses. So basically the student, you have to design, for example, you have to design the design of the staircase, or maybe have to design let's say you want to ensure that the room have a good thermal comfort, so you have to design air conditioning system, the system how you are going to design, or maybe the house how you are going to design. So that is a C6. So in this case, you're more on this analyzing. Okay, go back to your RPP. Okay, so now you know already. So next time, when you look at the lesson plan for every courses that you take, so you may look at this level, taxonomy level. If let's say C3, so the most of the question they will ask you to apply only. So using, okay, maybe you will know that one, that information, just get from the information for the question and then you apply to related topics. Okay, if C5, that means you have to evaluate, you have to justify which one is better. So you have to choose and you have to explain maybe. Okay, so if let's say C6, you have to design. Okay, so we go for the second course learning outcome. Okay, critically organize a presentation or report for a guided PBL assignment or project. So in this course, you have to do the PBL project. So I won't put in assignments, but I will put in a project. Okay, so this one is P4. Okay, so now I already explained about the cognitive level. So now you can go and find what is a P4. It's a similar things. Okay, this one is more on the level, cognitive level. If you want to find, you can go and find this one. You just search this one for a P is a psychomotor. Okay, this one, P. This one is P psychomotor and affective. 1, 2, 3, 4. And then kalau lah effective, kalau macam ni lah, kalau you see this one, okay, this is the psychomotor domain. 1, 2, 3, 4. So articulating. So your based on this one is based on your report. Okay, so if look at your this cognitive level, we only assess based on your quiz, your assignment, your task, your final. But see this one, your learning outcome for this course, the second and third one will solely based on your project only. So this is 7.5 marks, 7.5 marks for this cognitive level. this psychomotor level, and this is effective. So the third learning outcome is independently demonstrate lifelong learning in a guideline PBL project. Okay, so yang ni akan 7.5 marks, 7.5 marks. So the rest out of 100 marks, we will test you based on this cognitive. Maksudnya use your brain now. Okay, so I guess you already know that we have 12 PLO in our FCAP faculty. So if you don't know, you just can go. Kan? Awak pergi je FCAP punya faculty, this one, and then you just go to the website, and then go to the program undergrad bachelor. Okay, sorry, should be like edukasi. Ada je bawah. This one bawahnya. I think this one, sorry, this one should be this one program. This one, outcome-based education. So you can go and see. Okay, yang ni adalah semua PLO, 12 PLO of our faculty. So if let's look at this, this one. So you will, in this course, we are mapping this course with, you will get the outcome based on the program learning outcome PLO1, PLO5, and PLO12. Kalau lah PLO1, you can do here, can see this one. PLO1 is regarding engineering knowledge. So at the end of this course, you can apply the engineering knowledge, okay? And then 5 is modern tools usage. So that means you have to use either PowerPoint or anything, maybe MATLAB if you want to do in your project. But we didn't teach you, but this one you have to apply when you are doing your project. So mungkin awak kena belajar macam mana nak buat video, using the modern tools. Okay, and then the last one is the lifelong learning. Okay, so these 3 PLO that we'll cover in this course. And for the CLO1, okay, the assessment method will be quizzes, tasks, assignment, final exam. And then for the CLO2 and 3 is the project and your presentation of your project. Okay. Okay, so I now go to the lesson plan. Okay, for this semester, we will go for online. Okay, won't go for physical. Ke ada yang nak pergi kelas ke? I didn't, saya takut, I quite scared because the cases is still a lot. Tak berani saya nak buat face to face. But basically, only in the FCAP, we only have the face-to-face for the laboratory courses only. For the other courses, we will still maintain to the online, right? Okay, so in the first week, you will learn in chapter 1, Introduction to Numerical Analysis and Error. So in here, you will have to know what is truncation error, macam mana chopping off dengan round off. And I guess that this one is a very short chapter 1. And then we directly go chapter 2. So nantilah kita masuk terus hari ni non-linear equation. So chapter 2, the first one is locate the road using the intermediate value theorems. And then next week, we will continue with bisection and Newton-Raphson methods. So this is another 2 methods. Next week, we will cover. And then chapter 3, very sorry, right? This one, ada yang tak nampak tau. Tapi memang dia dah fix, dia tak boleh besarkan. The template is given to us. From the university is fixed. We cannot move anything. We cannot make it bigger or smaller. Cannot. So kadang-kadang tak nampak, kadang-kadang inilah terlebih besar. Okay, so chapter 3 is about system of linear equations. So basically, this chapter is quite big and quite important. It will come out with your test and final. Okay, Gauss elimination with partial pivoting, and also LU, decompositions, Koleski methods, Thomas methods. And then the last one, this one, Gauss-Seidel iteration methods. So chapter 3 is a quite big chapter. Daripada sini 3.1, we have 3.2 LU, and then 3.3 Thomas methods, 3.4 Gauss-Seidel iteration methods. Chapter 4, interpolation. Chapter 4, interpolation, we have 3 small chapters. Lagrange interpolations, okay, which we will cover in week 4, and then week 5 we will continue with 4.2 Newton divided difference methods, and then natural cubic spine. So far okay semua? Belum tidur kita baru mula.
Okay.
Okay, and then chapter 5. This one is a very short chapter, okay. Although it's look like a lot, but this one is just using the formula. It's very how to say? It's not so difficult compared to other topic. This one is much more straightforward. First derivative, we have 2 point forward, 2 point backward, 3 point central difference, 3 point forward, 3 point backward, 5 point difference. For the second derivative, we have 3 point center and 5 point center. And then chapter 6, numerical integration. So numerical integration, we have actually 3 methods. One is 1/3 Simpson's rule. The second one is 3/3 Simpson's rule. And then the third is 2 point and 3 point Gauss quadrature methods. Okay, and then we continue with week 8, agent values. So this one will have power method and shifted power method. Chapter 8 regarding ODE, ordinary differential equations. So in chapter 8, basically we have 3 subtopics. The first one is initial value problems and Euler method, or basically this is already 2. And then 4th order Runge-Kutta methods, RK4. And then continue with boundary value problem, finite difference methods. And then chapter 9, we have in this subject, we have 9 chapters. Okay, chapter 9 is PDE, partial differential equations. So PDE, we have 3 subtopics. The first one is heat equation using 2 methods, explicit, finite difference, and Kronig-Nielsen method, or implicit. One is explicit, one is implicit. And then the second subtopic is wave equation using explicit finite difference method, and lastly Laplace and Poisson equation using explicit finite difference methods. Okay, for the assessment, so we have quizzes. I want to ask your opinions. You want to have more quiz or only 1 quiz and I will get that mark for your 5 marks, or you want to get like 3, for example 3 quizzes and I will choose the highest? Macam mana? Amira? Are you here?
Yeah.
Awak rasa ni awak nak macam mana kalau quiz? 1 ataupun 3 pilih yang tinggi? Ke macam mana?
Pilih yang tinggi.
Pilih yang tinggi. Is it majority? Majority want to get more, maybe like 3 quizzes, 3 or 4, depend. And then we get the highest mark.
Yes.
And then it can be become part of your exercise as well. When you have more quizzes, that means at least you have like do more exercise. Okay, so probably I will choose like 3 out of these 3, will choose the highest. And then assignments, 5 mark assignment. So this one I haven't decided. Either you want to do in group or in individual. So basically, I will give in group. It will be more. Apa Siti Sarah nak cakap ke? Siti Mastura nak cakap ke? You want in group or in individual? Semua nak
group, Doctor, group. Discussion.
Group, okay. I will think about it. Apa yang nak buat untuk assignment? So maybe assignment later on lah. So and then test will be on week 8. Okay, Tarikh test dah ada So please save the date, okay? So kalau ada lecturer lain nak adakan test pada hari tu, awak kata dah ada test I have to choose earlier because we have like few sections. So in order to avoid student have other tests, so we conduct on week 8. Okay or not? Week 8 Friday. Nampak kan saya punya announcement kan?
Nampak.
Okay, so far okay, right? You save the date, okay? And then project 20 marks. Okay, project 20 marks, test 20, assignment 5, quiz 5. So, and then final 50 marks. Okay, before saya pergi selanjutnya, I would like to remind all the students, do not copy your friend answer during the test and also final. Jadi, ini saya cakap sebenar. Last semester, a lot of students cannot score. Why? Because a lot of students copy answer from friends. So I don't know who copy who. Once I notice that this is, I'm not sure whether this is an honor or the person who copy, so we'll get 0 mark for that questions. So ramai yang tak dapat score. So out of, I think the last semester, 360 something, only few get A, ada juga A plus, A. But some section even don't have A student, don't have A my students. Kesian sangat. So try, avoid. Jangan because why? I give you advice. Because last time when we do a final exam, some of the questions you have to input based on your matrix number. So kita senang nak trace tau siapa yang meniru. Sebab kalau meniru, dia kadang-kadang dia tak notice that their friend matrix number berlainan dengan dia. So kalau matrix number awak tak sama dengan jawapan, that means you are copy others. So we assume that the student is copy others, so get 0 mark. Tak ada markah, kesian tau. Kalau lah at least betul matrix number dia, cuma cara dia buat salah, okay, at least got some marks. The methods is still correct. Only the answer is not correct. So you get some mark there. If you copy, we know that we copy, that you get 0 marks for that. Ada yang, because some questions, one question is like 15 marks, 12 marks. So gone already, 12 marks, 15 marks. Kosong terus, okay? So I just want to warn earlier, try do not copy your friend's answer, okay? Okay, so far any questions? And then these are some books. Oh, so I already mentioned to you, right? We will use this numerical method with Casio FX 570EX plus, this one. But actually, now I guess that I'm not sure. Dalam Shopee kan ada yang dah beli ke? Tapi kalau what I heard from the penerbit, they still do the printing. Last time is not so expensive like this time, but because the printing cost is increased, sekarang mahal printing, so diorang kena jual mahal sedikit. Last time can get like 20 something, 28, 29 ringgit for one book, but this time macam tak boleh. Have to get like 30 something ringgit, include postage lah. So kalau lah ada sini yang nak jual, you can buy the book from them lah if you want, get the cheaper price. Okay. Okay, so make sure that you attend 80%, okay, of this, able to sit for your final exam. Okay, so far any questions for your lesson plan? If you don't have questions, that I'm go to the lecture. Semua okay ke? Are you here with me, guys, girls, boys and girls, boys and girls? Are
Yes.
Okay.
Still here.
Okay. You know why? Because I think like few times already, I went out from the meet, then I speak alone. for like more than 10 minutes. Then I just realized when my students give me message or call me, because I put my phone in the silent mode. So even they message or WhatsApp, I didn't notice. So talk, and then suddenly I'm not with them already. No wonder it's so silent. So at least you give me some some feedback. Then I know you are with me. Okay, so we start with the, I close this one. Okay, so we go for the chapter 1. Wait, let's go to the chapter 1. Sekejap, saya malu juga, saya nak tulis-tulis, lepas tu awak tengok je muka saya. So can I just close the webcam?
Sure.
Okay. So this one, we start with the first chapter, chapter 1, Introduction to Numerical Analysis and Error. So in this chapter, we will cover 2 subtopics. The first one is truncation error. So truncation error including chopping off and round off technique. And the second one is absolute error and relative error. Okay, do you know why we learn this numerical method? Any idea or not? Why we learn these numerical methods? Tak ada. Semua diam je. Saya seorang ke dalam kelas?
Don't know.
Don't know. Okay. Okay, let's explain. Okay. In our science and engineering lah, I say science and engineering, basically we can solve the science and engineering problems using the first one. We can use experiment. This one is very straightforward. So we get data. For example, you want to know the compressive strength of the concrete, right? So you can do using experiment. This one is the first one, right? And some cases, when the experiment we cannot carry out because sometimes because of the sizes of the things of the problems that we want to solve, or maybe because we cannot do it, for example, earthquake. So we only can do simulations. So takkan kita nak jadikan semasa adanya earthquake kita baru buat experiment. So we cannot do that one. So the second method, we can solve the science and engineering problem using simulation. So sometimes we can use simulations. And the third approach that we can use is mathematical models. So mathematical models, ni lah yang kita belajar, right? Maths. Why you learn math in this your civil engineering punya program. So for the mathematical models, we have 2 approach. The first one is analytical. So in this analytical, you can get the true value, the exact value. You get the exact solutions. So this one actually you already learned in your previous math, that is calculus and engineering mathematics. When you do the integration, you get the answer. Okay, but we have another approach that we can use is using numerical method. Why the numerical method is actually just a approximation solution only. It's not the exact value. Approximate solutions. Okay, why? Because for example, I give you an example. If let's say you want to know, let's say a beam, how many maximum load that can be imposed to that particular beam before it get to the maximum diffractions. Katalah, kan, that is a beam. Satu beam ni kan. Okay, so you want to know what is the P maximum, so that dia punya diffraction ni, you can know this one, diffraction ni. yang diffraction maximum supaya dia tak melebihi maximum. So what this, okay, let's say in the analytically, you solve this P, the load, let's say you get like 985.2538 Newton. Okay. But in the science engineering, in engineering, adakah, is it really necessary to get this so sangat jitu macam ni? Perlu ke kita dapatkan begitu jitunya? So exact. So for the engineering, normally we can just, we just want this value basically for design, right? Design the bill. Let's say we want to design the bill. You want to know this load. So actually we just can get the approximation value also okay already for the engineering. Let's say this one maybe can get 990 Newtons or maybe 1000 Newton. Dah. Kan? As long as the beam will not get the maximum diffractions. Okay, so that's why we learn numerical methods. So in order to make it us more easier for the calculations, kalau analytically, kadang-kadang is more very complicated. And in some cases, the analytically cannot get the exact solutions. So we go for the numerical methods. Kadang-kadang dia tak dapat nak solve. Katalah kena beza banyak kali tu dengan unknown that you don't know, and then so it will be a more simple way using a numerical method. Okay, so if let's say this one katakanlah, if let's say go back to this one example, if you have this one, let's say this is a exact solution, this is a, and then let's say we use this one as a approximate. Kau tengok kan, mesti kat sini ada error, some error. Mesti ada error. Sebab yang ni kan, let's say, you kan kalau sini, if let's say you take 990 Newton minus 2538 kan, dia mesti ada something value yang kita tak masuk. So this is error actually. So that's why you need to learn this truncation error. Okay, so far okay or not? Okay, so far I just explained to you why we learn numerical methods. Okay, why? And then now we go for the 1.1 topic of 1.1 truncation error, chopping off and round off technique. Boleh If I'm too fast, you just let me know. Ada yang nak saling ke? Snapshot, print screen lah. Okay, we go for the truncation error. Okay, so normally you learn daripada sebelum ni kan dah biasa guna decimal places kan? Decimal places, right? Let's say pi. Pi we have, katalah pi kan? Mana calculator? Pi, shift pi. Let's say the answer of shift pi. 3.14159264. 3.1415 apa dah 92654. Okay, if let's say we want to write this pi in 3 decimal places. Ini yang biasa kan, yang kita buat 3 decimal places. So pi become, nak besar sikit lagi ya, pi become 3.142, right? Okay, kalau ini adalah round off. Kenapa dia keluar ni shit? Okay, so ini kan 3 decimal places kan. So this one we already round off. This one is round off technique. Sebab kita dah bundar masuk. Kalau lah chopping, that means 1, 2, 3 and then you just chop. Chop saja. So it's become, if let's say pi is 3.141. So this called chopping off. Okay, boleh ke? Saya terlupa. Saya tak perlu record You record sendiri ke macam mana? Saya sekarang dah tak boleh record tapi saya boleh guna yang ni. Saya try record. Baru teringat. Dah habis lah. One section. So, okay, decimal places. This you learned before. Okay. This is decimal. This is decimal places. Okay. So, another one. Okay, this is the normally that you use, that you learned before. The second one is digit. We call it digit arithmetic, or we also can say significant digit. Okay, kalau lah using this digit arithmetic. Okay, if this we are using the same this one still using this one pi. Kalau lah, let's say I want 3-digit arithmetic. Okay, 3-digit arithmetic pi. So kalau lah, let's say I using round off, pi will be equal to 3.14 digit. Kalau digit yang 3 ni termasuk, yang depan ni termasuk. Sorry. Kalau decimal tadi kan kita kira yang belakang saja kan, belakang perpuluhan. After this one kan selepas perpuluhan. Kalau digit yang depan tu termasuk juga. Okay. Tapi if let's say for the digit arithmetic, if let's say we got 0, it will be different. I give you example. Example apa? Okay, example Let's say we have 0.14578. Okay, let's say like this. Okay, if let's say this one, I want to get 3-digit arithmetic. So kalau 3-digit arithmetic, the 0 in front is not counting. So if let's say I want to get 3-digit arithmetic by using round off, katalah. So become pi is equal, sorry, pi pula dah. Bila ada pi. 0.14. Ya. Kejap. Sudah hang. 146. Boleh. Kalau lah chopping off, then it will become 0.145. I just chop here. Jadi, in front the 0 here is not counting. Okay? Dia macam decimal. Tapi, kalau lah belakang. Okay. I ask you this one. Cuma saya nak tanya. How about this one? If let's say 0.140. 2-digit or 3-digit? Teh Hing Yu. Any idea? Okay. Mukri, berapa digit ni 0.140 ni?
3 digit.
Yeah. Ikut Teh je. Ciala.
2 digit.
2 digit. Fahmi? Fahmi here, Fahmi?
Yes, sir.
Agaknya 2 ke 3 digit arithmetic. Kalau 0.140.
3 digit.
Okay. It can be 2 digit and it can be 3 digit as well. Boleh tak? Dia boleh kira 2 pun boleh, 3 pun boleh. Kalau lah kalau yang belakang ni ada number, okay, that will be different. So this one become 1, 2, 3, 4 digit. Okay. Boleh. Kalau ini dia boleh 2, boleh 3. Kalau lah this one. So this how many digit? Daniel. Awak angkat this one how many digits? 0.000143. Daniel.
6 digit.
Okay. Siapa lah? Liana Aida. Liana Aida? No, Liana Aida.
Yeah.
Agaknya berapa digit?
Maybe
6 digit Atika? Atika agaknya berapa digit? Sebuah stres lah ni. Saya punya kelas jangan tidur Tak dapat nak tidur. Atika, are you here Atika? Siti Atika?
yeah. Sebab ada 2 orang Atika kat sini. Confused.
I'm sorry. Ada 2 Atika rupanya. Okay. Agaknya berapa digit? 3. Okay. So, this is 1, 2, 3. 3 digit. Because kalau depan dia tak kira tau. If in front is not counting. If behind it can be count or it can be boleh kira ataupun boleh tak kira. Boleh faham? Okay? So digit arithmetic dia macam ni. Kalau depan tu dia tak kira. Kalau belakang dia kira. Okay? So I move. So far any question or not? Boleh ya Atika? Bagus Atika. The rest tadi. Saya pun tak ingat lah saya panggil nama siapa. Okay, so we go to the, maybe we go to example. Saya dah paste ni belum? Tak ada. Let's go to the example. Okay, this one is actually example in the books. I just get from the book. Ini dalam buku kalau, if let's say, ada yang ada buku tak? Minta dengan senior ke? Kawan ke? Ada yang dah ada buku So if this one, example 1.1, this one in page 4. Page 4. Dalam buku yang saya share tu lah ya. Numerical method tu. Okay. Example 1.1, given that, okay, okay, A and B lah difference. 3/7 plus 5/6. Okay. Perform each of the above computations exactly using 4-digit chopping arithmetic and using 4-digit rounding arithmetics. Okay, we do A first, okay? Kita buat A dulu. Okay. Lama, bergerak. Saya pun pening ni. Okay. A 3/7 plus 5/6. Okay. Sama dengan. So this one we use calculator. Kalkulator tu paling besar lah. Boleh nampak kalkulator saya. Paling besar. Saya tak boleh besarkan lagi. This is the maximum already. Okay. So saya akan key in kan 3/7. 3/7 plus with 5/6. Okay, so equal to, so we'll get, kita dapat dalam pecahan. So memang pecahan itulah kita salin. Sebab kalau let's say you change in the decimal places, mungkin dia habis kat sini. Tapi kadang-kadang kan decimal places ada sampai hujung sekali tak habis. So mungkin belakang tu ada lagi some value. So kalau boleh, for the exact solution, we will choose kita pilih yang pecahan. Okay? Answer yang dalam pecahan ni. So it's become 52 over 52 pula. 53/42. Saya buat macam ni. The first one, this is the exactly. So yang ni sama dengan 53/42. Boleh? Lepas tu, kedua is 4-digit chopping. Arithmetic. Okay. Go back to just now equation, this calculator, saya tekan decimal places. Okay. So yang ni kan adalah saya kecilkan ini dulu lah. Tak nampak nanti. Oops. Put here. Dah zoom dah. Zoom 3 kali dah. So, kejap saya tulis dulu. Dia sama dengan 1.2619047. So now I want to get chopping. Chopping 1, 2, 3, 4. So this and then chop. So become 1.261. Okay. And then if let's say 4-digit rounding arithmetic become 1.262. 9 round up. Okay. Okay, this one is simple. So another one is B. 3/7 minus 5/6. So this one 3/7 minus 5/6. So sambil-sambil tu awak pun gunalah kalkulator awak. Dapat apa? Saya taklah tekan sama dengan. Nurul Fatimah, awak ada tekan tak? Nurul Fatimah. Okey, dapat apa?
Sekejap Negative 17/42.
17/42. Okay. So, thank you. This is the exact value. We get negative 17/42. So, kalau dalam perpuluhan decimal places, tipo. In decimal places? Decimal places, what do you get?
Negative
Hmm.
0.4
0.4,
04
04,
76
76,
19
19,
04.
04. This one.
Yeah.
Okay, thank you. Okay, kalau sini, now we go to the alamak. Ui. 4-digit arithmetic. Okay, this one 4-digit arithmetic. Yang depan tu tak kira. In front we not counting. So 1, 2, 3, 4. Apa dah ini chopping kan? Silap. 4-digit chopping. So become negative 0.4047. And then for the 4-digit rounding. Matic. So kita round sebab because this one is more than 5, then we will round up negative 0.4048. Okay, so this is the answer. Exactly the exact solution and a 4-digit chopping arithmetic, 4-digit rounding arithmetic. So ini. Okay or not? Class, okay? Semua okay ke?
Okay, Doktor.
Okay, now we move to another example. Example 1.2. Sekejap saya sangat dulu gerak ke sana. This one. Ada yang nak copy ke? Tak ada? Tak ada eh? Assume tak ada eh? If I'm too fast, you let me know, okay? Okay, now we move to example 1.2. This example 1.2 is actually in page 5 in that book. Okay, given an irrational number pi equal to 3.141592654, find 5-digit representation by pi by A is chopping off technique, B is rounding off technique. Okay, ini saya terus panggil sajalah nama. It's very simple. Auni Nabiha. A. Apa A?
Ya, saya.
Kalaulah pi equal to 3.14 ini kan. Pi equal to 141592654. Sekarang saya nak cari 5-digit chopping off technique. Dapat berapa?
3.1415.
15. Okay. Bagus.
Terima
And-
kasih, doktor.
Okay. And then for the rounding, 3.1416. Right. Okay. Simple, right? Okay, kita dah habis truncation error. Okay. And then semua boleh Okay. So we go to the error analysis. Boleh semua? Mafira. Okay ke?
Okay.
Okay, so we go to the error analysis. Another topic. Okay. Saya tengok dulu. Okay. So just now I mentioned to you, right? When we have exact solutions, okay. When we have a exact solution, actually exact solution adalah is the approximation plus with the error. Okay, so this exact solution is, that means this is the true value lah. This is the true value. Okay, so yang tadi saya kata lah, tadi kan yang beam tu. So you will have the error. We do the approximation plus with error will equal to the exact solutions. So the error can be positive or it can be negative. So depend. Sebab kadang-kadang we overestimate. Kalau overestimate, we get an error, positive error. Kalau kadang-kadang we underestimate, so we will get a negative error. Faham apa saya cakap? Contoh tadi lah kan, let's say this one 253 apalah katakanlah unit. So katakanlah saya ambil this one, right? This approximation. So sebenarnya saya dah overestimate. So saya dah lebih estimate. So saya punya error akan ada positif lah. Tapi katalah saya buat macam ni, saya dapatkan this value. So this is underestimate. So dia punya error akan ada negatif. Tapi in this error in numerical method, dia tak kisah sama ada kita nak buat extra estimation ataupun under. Okay? As long as kita boleh how to say, kita tahu dia punya error tu tak boleh terlalu besar. In numerical method, we try to solve the solutions using the approximations by make sure that the error is not too big within the limit that can be accepted. So tak kisahlah, mungkin kat sini is, let's say this one terlalu besar. Let's say this one like this. Like 995. Boleh faham tak? So 995 is approximate to the 998, but then is underestimate. So the error is negative. As long as the error can be accepted, is not much. Okay. So that's why normally error, apabila kita buat kira error, normally we do in the absolute because it can be positive or it can be negative. So biasanya saya tulis kat sini lah. Lepas tu saya kena wait. Kan? Error. Because error is positive or it can be negative. So that's why most of the time we will use absolute. Absolute tu modulus lah yang macam ni. So kita tak kisah dia punya tanda positif ke negatif tu. So absolute error is equal to exact solution. Yang ni saya tulis exact sajalah, exact solution minus approximate. So in modulus. Macam ni lah. Katakanlah saya jadikan exact solution ni sebagai X. And this approximation is, let's say we use it as a X asterisk of star lah kira. Ada ni asterisk of star. So ini jadikan, oops. So become this one. So So this is a absolute error. And this absolute error this one, this formula, you have to remember. Because biasanya kalau keluar final ke exam, dia takkan bagilah formula ni. Awak kena ingat dia. Okay, so you have to know that absolute error is the exact minus approximate. Tak kisah ataupun approximate minus exact. Because after that, we will do the modulus, we will do the absolute. So the value won't be, kita hapuskan lah positif, negatif, tak kisah. So the outcome, the answer will be in the no negative value. And then kadang-kadang we also want to know about the error in dalam bentuk relative error. We call it relative error. Dia bukan pecahan tapi dia bukan pecahan lah. Dia bukan percentage, but dia dalam bentuk pecahan. Error. That means this is the exact solution minus approximate, and then divide by exact. Ataupun kita boleh cakap this is the absolute error divide by the exact value. Okay, so sama dengan kalau saya nak buat dalam this one, the formula. Macam ni lah. And this one also you have to remember. Ini kena ingat You have to remember absolute error and relative error. Kalau relative error kena bahagi dengan exact tu lagi. Exact solution punya value. Okay, so we go to the example. Okay girl, yang ni okay. Nur Alia, are you with me?
Yes, doctor.
Okay. Kalau lah, saya copy ke mana example. Kejap, saya cari buku dulu. Analysis, error analysis 1.4. Ada kat sini 1.4. Kejap, saya cari sebentar. Where did I put this one? Macam terturah. Tengok balik sini. Yang ni tak ada. Ada copy sini Tak apa. Never mind. I just write it, okay? Then I just write it. Tak ada 1.4 ada the copy 1.4. Tak ada. Tak apa. I just write it Saya tulis sajalah. So, example 1.4 in page 7. Awak ngantuk, awak beritahu saya lah. Kita stop dulu ke? Take 2 ke? Take 5 ke? Okay. Example 1.4, it asks us to find the absolute error and relative error of the value following given below. Okay, so A dibagi let x equal to 3.141592 and x star ni approximation value lah. That means 3.14. Okay, so we solve one by one. A dulu So this one, absolute error. Using the formula just now. Okay, so absolute error, ini exact minus approximate. Kan? So sama dengan ataupun, Ini minus ini. Okay. So 3.141592 minus 3.14. So kita dapat 0.001532. Okay, boleh? Very simple, right? And then relative error. So relative error, ambil je answer this one absolute error 005592 bahagi dengan exact value. The exact value is 3.141592. Okay. No, Syafiqah, tolong kira dapat berapa Syafiqah?
Ya.
Ah. Tengah cari kalkulator ke Syafiqah?
Dapat
Okay.
0.000506.
How many zero? 0.00? How many zero?
Yep.
Huh?
4.
One.
Lagi.
Lagi?
506.
506.
Yeah.
Depan
67.
67. Okay. 67. Okay lah, 67. Oh, okay, then I round off lah, become 7.
Okay.
Okay, thank you.
You're welcome.
And then we go to the B. B pula, saya salin lah. Dia kata a true value is, so banyaknya kosong, 1 million. 1, 2, berapa? 1, 2, 3, 1, 2, 3, 6. 1 million. And then estimation is, wow, 1, 2, 3, 4, 5, 6, 999 and 999,996. Okay, so yang ni cari pula dia punya sama. Absolute error is equal to 1 million. Betul kan 1 million tu 60. 1, 2, 3, 1, 2, 3. Betul lah. Saya tanya lepas tu saya jawab sendiri ya. Dapat apa ini? Congak ni kan? 4. And then this one relative error is 4 divided by so get macam ni. Ada 5 kosong. 1, 2, 3, 4, 5. Okay. Boleh. This one. And then C. The answer obtained from analytical, kalau analytical solution, biasa that is the exact solution lah, is 3/25, 250,000. And meanwhile, for the numerical method, the answer is 0.000509. So, kira absolute error is equal to this one minus dapat berapa? Nak panggil nama. Hisham Hussein. Are you here with me?
Yes.
Can you help me to calculate what do you get the answer for this one absolute error?
Okay, wait.
Yes.
0.00003.
How many
50.
zero, my friend?
5.
1, 2, 3, 4, 5. Oh, sorry. Len, the last digit is
3.
3.
Yes.
Okay. Thank you. Thank you, Ishan. Relative error becomes 0.12345. 3 divided by yani 3 over 250,000. Okay. Jasmine Murugia. Yeah, can you help me to calculate this relative error? What do you get?
Okay, Dr. Rita.
Yang lain ada tidur tak? Still with me, everybody?
Yes.
Yes, Jasmine, find your calculator already?
Yeah, fine, ready.
Okay, what do you get? What do you answer?
Wait, one.
0.25.
0.25. Okay, thank you. Akmal, betul tak? Akmal Kamil, is it correct? Iqmal, sorry, Iqmal? Iqmal Kamil,
Yes, sir.
correct or no?
Correct.
Okay, thank you. Okay, so finish already chapter 1. So we already cover truncation error, okay, regarding the arithmetic, digit arithmetic, and then round off, chopping off, and then error analysis, absolute error, and relative error. Okay, so done already chapter 1. So do you need have a rest for 2 minutes? Then we continue with chapter 2. Perlu tak? Take 2.
Perlu.
Okay, then okay, we rest for 2 minutes, then we come back. Before I continue, can I know Ahmed, is it here? Ahmed Mohammed? Ahmed Mohammed and Muhammad Shafiq, are you here? Tak ada eh? Tapi sini ada ramai kat sini. Extra 2 orang kat sini. Ada masuk 2 device eh? Termasuk saya lah. Ahmed, is it here? Muhammad Syukri, salah. Siapa kenal? Ahmad Muhammad and Muhammad Shafiq. Muhammad Shafiq. They are not here, both of them. Ada yang kenal, tak kenal? Ni Ahmed Mohammed, is it here? Ahmed Mohammed. Ke saya panggil salah nama? Is it I call your name correctly? Ahmad Muhammad Ja'afar Al Khalifa. Dia ada kat sini ya? Yes, Chua.
I saw his name in the Google Meet.
Yeah. Ahmed Mohammed. Are you here, Ahmed? I also saw the name here. Ahmed, are you sleeping? Okay. Apa? We continue, okay? Boleh? Dah okay bah? Okay belum? Dah 2 minit ke belum? Sekejap. Chapter 2. Okay. So, saya continue, okay? Macam kejar kapal terbang ya saya. Sebab, because why? This Wednesday don't have class because it's holiday, right? So, saya kena kejar. Okay. Then we go to the chapter 2. Okay. Kenapa ada sini ada example ke? Oh, okay. Only one example. Okay, never mind. Okay, chapter 2. Chapter 2 tak tulis apa lagi. Saya tulis dulu lah. So, Chapter 2 is regarding, the title of chapter is non-linear equation. So in chapter 2, okay, 2.1 is locate root. So using intermediate value theorem, and then 2.2 bisection and Newton-Raphson method. Okay. So what is linear equation first? Yang ni non-linear, tapi we start with the linear equation first. I bring this one to the other places. Jap. What's this? Linear equation. What is linear equation? Ada ingat tak pasal linear equation ni? Tak ingat. Afnan, Hilmi. Takkan tak belajar lagi? Linear equation. Equation yang macam mana? Yes.
Equation with only one variable.
One variable. Okay. Maksudnya ada X saja, tak ada Y ya?
Yeah.
Tak juga. Okay, never mind. I hear. Equations, linear equation, normally that is kalau lah graph is a straight line. Straight line. Have a straight line punya keturunan, straight line.
Y
Apa?
Y equal to mx plus c.
Yes, that one is the linear equation. Okay, so actually linear equation is the when the unknown yang x tu yang kata variable in 1 degree. Dia bukan kuasa 2, bukan kuasa 3. It's not power of 2, power of 3, no. It's a power of 1, degree of 1. So that makes it become a straight line. So X ni, dia bukan, is not like X kuasa 3 ke, kuasa ni, dia bukan epsilon ke, bukan ln ke, bukan sin ke, cos ke, bukan. So this is the linear equations. That means dia punya apa, keturunan that is a straight line. Okay, contoh this graph, let's say I draw a graph, this one lah, x, y. So for example, the graph like this. Okay, so, and this is the fx. So fm mungkin dia punya equation is like this. So this is b, intercept fb at b, ini kan. Okay, so mungkin ada juga, it can be positive. The A can be positive because it's a straight line macam ni, ataupun dia kemungkinan di straight line macam ni. Straight line macam ni. So kalau, if let's say this one, so the fx, the equation will be negative ax plus b. Okay, that means the degree of x is equal to 1. So it becomes the straight line. So if the linear equations, we want to find the value of x ke y ke, it will be very easy. Let's say, for example, let we have y is equal to 3x plus 5. Okay, kalau 3x plus 5, let's say I draw a graph here. Okay, look. Okay, let's say like this, and graph macam ni. So here, let's say here is 5 lah. Okay, so this is the graph y equal to 3x plus 5. So you can, let's say I want to find this value, x berapa. So from this equation, I can easily get the value of x. When here at this point, the value of y is 0. Kan y is 0 kat sini. So that means I can set this one, this equation, 3x plus 5 equal to 0. So I can get the x. So x is equal to, yang ini kan bawa ke sana, negative 5, okay, divide by 3. So at this point, this is negative 5 over 3. So very easily to get this value. So actually, this value, the value that intercept at x exit, this one, this value, intercepting at x exists, we call it as a root, R-O-O-T, root. Okay, so if linear equation, we can easily find the roots. But if let's say this is a non-linear equation, that means it is not a straight line graph. So it will be difficult for us to find this root, this value, the value of x when intercept at the x exits. Okay, let's say I give you an example of the non-linear equation. Okay, so non-linear equation. Tadi lukis apa? Oh, tadi biru, sekarang hitam. Apalah, doesn't matter. Okay, so non-linear equation, that means this is not a straight line. So for example, like this one. Contoh. We have the graph like this. It can be like this. Ataupun can be a graph like this. Mungkin dia ke bawah lah. Ataupun it can be the graph like this maybe. Okay, so this is a non-linear equation. So normally for the non-linear equation, some expressions, it can be like x plus ln x equal to 0, ataupun mungkin dia ada degree of 2, it can be, or maybe degree of 3, the x cubic, 4x cubic plus 2x plus 1 equal to 0. So this is non-linear equation. When we have all this equation, this time we is really hard. Kita nak tahu intercept kat sini, root kat sini berapa. It's really hard to find this root. Cannot be straightforward. So dia susah nak dapat kan. So for the engineering, why we want to find this root actually? But because in the engineering, we normally we try to find the roots in order to get the solving the zeros. We want to get when the y is equal to 0. So that's why we want to find this root in the engineering field. Okay, so we want to find the value when biasanya in engineering kan. We want to find the value, finding value of x when fx is equal to 0. Okay. So because this nonlinear equation is difficult, so we have one of the methods. Kat sini, this is the one of the methods. Ada beberapa lah, ada 3 We have 3 methods. One is this intermediate value theorem, and then another one is bisections, and another one is, the third one is Newton-Raphson. So today I try to cover this one lah. Okay, intermediate value theorems. Semua okay ke? Aimi, are you okay?
Okay, Doktor.
Okay, so I go to this intermediate value theorem. Okay, kalau lah, I repeat just now, when we have a linear equation, which is very easy to find the root. When we have a nonlinear equation, we are really hard to find the root by plotting the graph. Kalau katalah, we don't have the graph, we don't have the software, so we don't know. It's a bit hard to find the root. So, but we can try to find the roots using this intermediate value theorem. Di mana saya tulis value theorem dia cakap apa? It say let x, saya salinnya ni. If you have books, you can refer to the books in page 11. Say that if fx is equal to 0 is non-linear equation, if fx equal to 0 is non-linear equation, if fa times fb more than 0, then it is guarantee that exists at least, saya terlupa salin tadi, sorry I have to write all this one, root in the interval a to b. Okay, so yang ni theorem cakap, this one is what theorem said lah. Okay, what the theorem said, let's say we have fx equal to 0, this function is nonlinear equations. So if let's say we time fa times with fb, we get less than 0. That means between the interval A to B, that will be at least one root within that interval. I plot a graph for you to understand. So let's say we have a graph like this. Let's say this is the X, this is the Y. So let's say we have a graph like this. Okay, so this is a fx. This is a fx. Okay, so let's say at here this is A, and here this is B. Katalah interval. This graph is from A to B. Boleh? This is the interval. Okay, the graph is from A to B. Okay, so let's say if we find the value of FA, katalah this equation, right? Kita ganti, we substitute the value of X here with A. Yang ni saya ganti masuk. Awak tengok sini, this is the value of FA. What is this? This is a positive value, right? Okay. When I substitute these functions with the value of B here, saya dapat sini lah value this. This is FB. So look at here. This is a negative value. Okay. Kalau tengok sini saya darabkan FA times FB. Kalau tengok sini, this is a positive value, right? This one. Saya time with the negative value. So what I get? I confirm I will get negative value, right? And it is less than 0. So kalau tengok daripada graph here, you look at this graph. Did you see this one? This is the root. The value that intercept kat sini. This is the root. So apabila kita darabkan, when we FA times with FB is less than 0, that means between this range, this interval from A to B, guarantee at least one root exists in that interval. Boleh faham ke tak?
Tak.
Faham. Nak ulang macam mana? Kejap Apa yang saya kat mana tak faham ni? Saya nak cakap balik macam kat mana? The whole graph Auni. Aimi ke Auni tadi? Tak faham. Who are not understand? Wait Okay, I explain to you again Let's say we have a graph like this. Okay, let's say we have a graph. Okay, this is a X. Okay, this is a Y, and you have to know that what is root. Okay, what is root? Root is the value of X when it is intercept at X exit, ataupun the value of X when Fx is equal to 0. Boleh faham tak? If let's say I have a graph like this. Wait sekejap. Wait Sorry. Okay, we go back to this one. Okay, root is the X value that we want to find when we have a graph. Let's say we have a graph like this. Okay, kalau here from this graph, the root is at here. At this point, Y is 0, right? Y is 0. This value, at this value, Y is 0, right? X is some value. We don't know. Boleh faham kat sini? Boleh faham? Now, okay. Okay. So, root is the value of X when it's intercept at X exit. This is the X exit. Okay. That means when Fx is 0. Betul tak? You understand or not? Fx, that means Y lah. Y is 0. Okay. Let's say we have this graph from A. to B. This is interval from A to B. Okay, this graph is from A to B, this fx. Let's say this is a fx. Huh? This is a graph fx, okay, from A to B. Okay, and this intermediate value theorem said if okay, if let's say FA time with FB B is less than 0, okay, that means at least a road is between the interval A to B. Boleh faham? Kalau tengok sini when I put, let's look at this value. Look at this value. Yang ni apa? Yang ni kan? A kan, nilai A. X dia A kan? The X value is A. Saya ganti kan, I substitute the value of A into this fx. Okay? Fx ni can be any equation. This can be any equation. Okay? So I didn't put this on. This one is a non-linear equation lah. Okay? So I didn't put this. What is the function of this fx? So as long as this one is non-linear equations, okay? So I will substitute A into this fx. So this one will become fa lah, kiranya. Okay. I substitute value. So it will have like certain value lah here, okay? And here, when I substitute the value of x to B, so I get this value. Okay. This is value of x. But at this point, you look at here, the value of y, FA here, this is positive, right? Ini kan positive, yang ni kan negative, nilai y tu. Okay. At this point, this is negative. Boleh tak? Kalau tengok sekarang, apabila, because this theorem said, when FA times with FB, kalau tengok, if you look at here, this graph, FA is positive and FB is negative. Positive multiplied by negative, it will become negative, right? So for sure, this one is less than 0. So they are less than 0. So within interval A to B, it's guaranteed that it is at least got one roots between this interval. It can be many, we don't know, because now I put the graph like this. The graph for the non-linear equation can be like this, for example. It can be like this. If let's say like this, so it can have two, depend on that non-linear equations. Okay, so but at least got one root between that interval. Okay, boleh faham tak sekarang? Understand or not? Ahmed, are you here? Ahmed Muhammad. Sekarang boleh faham tak, Aimi? Masih tak faham?
Faham.
Oh, yeah. Okay. So now we go for the example. Maybe after example that you will understand. Okay. So I go to the example. Ambil example ni tadi. Mana ni? This one. Put it down here. Okay, example 2.2 page 2.1, 2.2, page 12. This one is on page 12. Okay, given the non-linear equation fx equal to 3x plus sine x minus exponential of x, for x less or equal to 0 and bigger than or equal to 1, show that that is a positive root by using intermediate value theorems. Okay, sekarang if look at here, it's given that this is the interval from x from 0 until 1. So ingat, this is the interval. So A is 0, B is 1. Boleh faham tak? So this actually is like this lah. Kalau saya lukis graf, dia maksudnya daripada from this one y, this one is x, from 0 here until 1. So within this one lah, within this one. So mungkin saya tak pastilah the graph of this one will be look like macam mana graph ni, saya tak tahu nak melukis, tak pandai. Okay. Okay. So now since, okay, now is fx macam ni. Fx sama dengan 3x plus sin x minus exponential of power fx. Yeah. So now, saya kena cari fa. Itu apa? I have to find what is fa. So fa, and then I have to find fb. And then I have to fa times with fb, right? Like this. So I want to check whether it is small or larger than 0. Small or larger than 0. Okay. So the first one, A. Just now I mentioned already, A is 1. So sekarang saya gantikan A tu dengan 1. Boleh faham tak? So now, this one is F1. Understand or not? So B is, sorry, F0. This one is 0. This one is 1. Boleh faham tak? So this one is, I will substitute the value of 0, substitute value of 1. Boleh faham setakat ni?
Boleh.
Okay. Now, we calculate the value of F0, F1. These two value. So the value, so I will key in the, okay. So saya akan guna calculator. So just input, masukkan this equation. I will key in this equation. Okay. So when you have like a lot of equation, find this one. Okay. So I will key in 3. X macam mana? So when I want to key in X, I will press the button alpha here. Alpha. And then there is a close bracket here. Is the X value. So it come out 3X. Okay, boleh? Plus. Oh, but then, okay. This equation got sign. If let's say equation got sine, cos, tangent, theta, anything, tangent, cosine. So make sure your calculation is in radian mode. Make sure in the radian mode. Boleh nampak R ni? This is the radian mode. So let's say, I close back. If let's say, because the default, when you turn on your calculator, the default is in degree. So make sure you choose the radian mode. Press shift and then mode here. And then choose radian, number 4. Okay. Now I choose number 4. Now it's already radian mode. Key in the formula 3. Okay. 3x is tekan x tu, tekan alpha. You have to press alpha. And then if you look at your calculator, there is a small x with a red color. Okay. So x plus sine. Okay. Sine alpha x. Okay. Tutup kurungan, and then minus, okay, this is exponential, here is shift ln, so you get this value, and then put in alpha x. Key in calculator boleh ke? Everybody, Adib, are you okay? Key in this formula into your calculator.
Okay.
Boleh? Is it all of you using this calculator? Some of you may using the old one, still sama juga. Yang baru pun boleh semua, tapi mungkin kadang-kadang dia tak sama lah. Tapi using this for this equation so far, okay, all are same. Okay, now I will press solve. This one, shift, calculate. Okay. So, solve the value of x for x is 0. Betul lah? Ni kan saya nak ganti 0. I want to substitute the value of x is 0. So, just put 0 lah. So I will get 0.3. Salah. Betul. Kejap. Calculate. Sweet. What is x? Silap. Tekan calculate. Tekan calculate. What is x? X is 0. And then I press equal. So I get the value is -1. So here, when I substitute this value x with 0, I will get -1. Boleh faham sekarang? And now I want to substitute the value of x to 1. So press calculate. X is 1 equal to, so I get the answer is 1.123. 1.1232. Okay, boleh. Now I want to calculate this one. Equal to -1 times with 1.1232. So I get -1.1232. So this is negative value. This is more than 1. So that means FA times FB is less than 0. So therefore, there is a road in the interval 0 to 1. Boleh faham? Because this is the negative value. Because this one we get less than 0. So between these two intervals, A to B, that means 0 to 1, we got at least a road there. Boleh faham? Ashraf, okay or not, Ashraf?
Okay.
Okay. Boleh? Kalau dalam buku, in your books, don't have any other exercise already. Example, only this one. So far, okay or not? Or we need another example for this one?
Doctor, another example, please.
Another example, okay. I do another example. Let's say, given x plus ln x is equal to 0, okay, show that there is a road in the interval 0.2, 1.0 by using intermediate value theorem. Okay. It's given, okay, this one is fx. Ini kan fx kan? This one is fx. So here, this is A and this is B. Okay, boleh. So now I want to have to calculate FA. Right. FA, that means saya kena gantikan nilai this one X. Tuh. So ini maksudnya saya akan perlu gantikan A itu adalah 0.2. 0.2 plus ln 0.2. So what we get? Boleh faham? And then FB, that means saya kena gantikan B is 1. Gantikan X tu dengan 1. 1 plus ln 1 is berapa? Okay. So now I just key in using calculator. It's more easier. Just key in the formula here. X plus ln X. So here I press alpha X. Okay. Plus ln. Kat sini ln alpha X. Okay. Tutup kurungan. Tak tutup pun tak apa. You want to close or don't want to close also can. So and then press calculate. So now you will ask, what is your X? What is your X? Now I want to find X is 0.2. Saya gantikan 0.2. So here I will press 0.2. So I will get negative 1.4094. Okay. Now I want to calculate another one is when I substitute the value of X with the F 1.0. So we get, now what is calculate? X is 1. Okay. Sama dengan equal to. So you get the answer is 1. So now we FA times FB. That means F 0.2 times with F 1.0 is equal to negative 1.4094 times with 1. So we get negative. So that means this one is less than 0, right? So less than 0, therefore, there is at least a road in the interval 0.2 to 1.0. Boleh faham? Can understand or not?
Boleh, boleh.
So I think that's all for today class. Dah banyak sangat nanti pening. Saturated already your brain. So far, any questions?
No question.
Okay. So then I stop. So if no questions, then we will continue our class next week because this Wednesday is holiday. Okay. So see you next Monday. Okay. So dah boleh lah.
Thank you, Doctor.
Okay, thank you.
Welcome.
Terima kasih.
Welcome.
Terima kasih, Doktor.
Ahmed, are you here, Ahmed?
Thank you, Doctor.